Hi, this is Professor Stugard, and in this video we are going to discuss functions in R. So our goals for this particular lecture are going to be understanding how the functions work, their different parts, and the way we format them, and then also how we can write our own functions in R to hopefully make our lives a little bit easier. So we've already used functions a lot. We've been using them since day one. But sometimes it's good to be able to write your own functions. So even though we've used them, and hopefully we should kind of have an intuitive idea at this point about how our different functions work, let's talk about it specifically and really get into the details of what makes up a function, how a function works, and then of course how we can create our own. Now, the main concept here is that a function is a verb. It is something that we do. It is a set of instructions or operations that we perform. And we do want to make sure that we kind of keep that in mind, that that's really what our function is about. Our function should do something, should perform some sort of task or act out some sort of action. Now, our functions consist of several different parts. First of all, we have our inputs or our arguments, which are also called our formals. So again, that's what we're putting into our function. Then we have our body of code, which is the instructions. It's the actual operations that our function is going to run through. And then lastly, there is the environment. So the environment is not something we're going to talk about too much, especially in our introductory course. But the environment is where the function actually does its work. It tells R how to look up the variables, and it tells R really where and how to run this function. Now, it is useful in some aspects for us when we look up particularly the help information about our function, because it will tell us what package it is a part of. So again, typically we're loading the entire tidyverse family of packages because, well, it's just useful to load all of those at the same time instead of one at a time. But if you do feel like you can just use one at a time, or you don't need every single thing in the tidyverse and you want to make your code run a little bit quicker, you can look it up, and in the environment part will tell you what particular package it is a part of, whether it's part of the tidy R or purr or string R. So that is really the only useful part for the environment for now. But again, it is kind of useful to remember that your functions are existing somewhere. This work needs to be done somewhere in the computer's memory, and that's what we mean by the environment. Now, our functions are really like any other objects in R. And again, if you take more programming classes, you'll learn more about what's meant by objects. But really, it's an object, so it exists in the computer memory somewhere. And so we pull it up by its identifier. So again, every function has its own name. That name is its identifier that tells us how to pull it out of the computer's memory to use, right? Everything has that particular identifier that goes along with it. All right, so the first thing I want to talk about, though, is our arguments. So when we run our functions, sometimes we specifically declare what our arguments are, although we don't always necessarily have to. So, for example, with the ggplot function, we can specify our very first argument as data equals. So again, the first argument is the data that we're going to use. Now again, a lot of times I write this with the piping function. We just pipe it in because, again, typically the very first argument is always the data. And I think piping is just a very useful tool to use, and it's how I learned to program. But again, we can actually specify it first. So data equals pets. And then the next one would be mapping. Again, in our ggplot function, the next argument is mapping, and mapping equals AES. And you might even have seen that when we were doing different examples. But I can leave it out because you don't always have to specifically declare your arguments, because ggplot knows, all right, well, the first one is data, the second one is mapping, and even though he didn't say mapping equals my aesthetic function, I know, I got it, don't worry. And so I can leave it out. And then in my aesthetic function, well, then we have our x's and our y's. So again, we have arguments for ggplot, which in this case, my first argument is what is my data? My data equals my pet's data frame. And then my second is I have a function inside of a function. My aesthetic function has its own arguments. And again, typically it has its own arguments for the x variable and the y variable. Now, if I'm trying to write really, really quickly, I can leave all that out. ggplot pets, comma, AES is height and weight, and R is going to know exactly what that means. It's going to supply everything in the order that we put it in, assuming that we did everything correct. But that's not always a good way to do things. So the leaving out the data equals pets is fine because, again, typically we know that every argument, the first argument for almost every function is the data that you need to use. That's almost always going to be the first argument. But with the aesthetic function, the AES, that's not really a good way to do it. Even though, again, we know that it goes x, y, we should really write it out with x equals, again, in this case, height, y equals, in this case, the weight, but we should absolutely write that out in our aesthetic function just so it's really, really easy to read. Because, again, the program knows what to do, but a lot of times you're going to have to go back to your code. You want to read it later, maybe someone else wants to read it later, and specifically defining what is your x variable for this particular plot, what is your y variable for this specific plot is very, very important. And then, again, remember, because a lot of times we also filter inside of our aesthetic, like we filter something by, you know, in this case, species or something, who knows. And we write like another argument. The next argument would be comma, color equals, and then again, whatever variable we want to filter by. So, again, a lot of it is making sure that it's readable. You can make your code work really ugly and just make it, you know, like R does not care how pretty you make your code look. You're really doing this for you and for any other human who might eventually have to look through your particular code. Now, with the arguments, again, most times R is going to supply those default values for arguments if none are given. So, for example, let's say I stored the value 2.17 in my variable x, and I call my round function. I say just round x. Well, when I say round x, it's going to spit out the number 2. Because there was more arguments for your round function, and in this case, the biggest one would be how many digits to round it to. And if you don't supply that argument, R is going to say, well, they must have meant digits equals 0, round it to the nearest whole number, and that's the default. That's what it's going to be. Now, if we want to do something different than rounding it to the nearest whole number, we need to specify that particular argument. So let's say, again, I start with my 2.17. If I want to round it to 1 decimal place, I need to now specifically define that I want my digits to equal 1. Round it to 1 digit past that decimal point, and now when I run it, I get 2.2. And so, again, there's those default values for arguments, but we can overwrite them if that's what we want in our functions. And again, the best place to start, if it's not working exactly right, is to use that help function. So question mark round, if you type that in the console, then in that bottom right corner where your help file is, it will pop up with all the different arguments you could use and the different ways we can actually use the rounding function or different functions in the rounding family, because there are actually different functions in that rounding family as well. Now, missing values. So missing data is a huge thing that shows up all the time. And again, a lot of times we try to clean our data set up beforehand, but sometimes that's not always possible, or sometimes it's missing like one data value, but there's other data there for that observation, so we want to make sure we keep it. Well, if we try to do things like, say, find the average or find the mean of a vector where there's missing data, the computer's going to spit out an error message saying that there's missing data. And again, like I said, we could go through and clean it up, or we can typically include as one of our last arguments na.rm equals true, which basically stands for if a data value is NA, if a data value is missing, then remove it and then perform the function. So again, if we include that argument, that will make it so that it removes any of your missing data, because RM is actually a function itself. The RM function is how we can remove objects. And so you can use the RM function. So let's say you're again exploring a data set, you're doing a bunch of exploratory data analysis, you're creating a bunch of data frames, and all of a sudden your environment is getting very cluttered. Like you have 20 data frames up in your environment and it's very cluttered. You can actually use RM and supplies the argument the data frame, and it'll remove it from your environment. Just be careful, because again, you can't undo that. Once you remove it, it's gone. The computer does not say, oh, well, maybe he still wants this a little bit later. Nope, it's gone. So again, use it only if you know you really want to get rid of it, but it is a really nice way to kind of clean up your environment. And again, you can remove anything you want. So you can remove values or vectors or data frames. So it is kind of a nice, useful function to just, well, clean things up as you're doing your analysis. All right, so variables in your function. So when you do a function, when you run your function, it is typically going to run separately from all of your other code, which means if you define a variable outside your function and you run a function and that variable is in your function, it's going to retain that original outside value even after it's done running, unless you specify otherwise. And again, you can specify otherwise, and sometimes you do want to retain that value. You want to keep whatever it was that was done inside of your function, but R will not do that by default. Basically, what happens in a function is going to stay inside that function. So whatever is done in that function, again, it's going to do the operations. It's going to perform that set of instructions, and then it'll return a value when it's done, but it doesn't affect anything else that's happened. The function runs in its own kind of isolated silo, unless you specifically tell it otherwise. All right. So again, just remember when you run your functions, and again, this is more for when you're creating your own functions and you want to save values or whatever. It does not happen by default. But let's actually talk about writing your own function. So when you create your own function, the first thing you need to do is, well, have an identifier. It needs to have a name. So I'm going to do my underscore function. Now, this is a terrible name for your function. I probably shouldn't have named it this, but I want to create my own function. Remember, your function is supposed to be a verb. So when your function is a verb, it should be an action. When you name your functions, it should be an action word. It should say what the function is going to do, so that it makes sense, again, for the humans who have to read your code later on. R doesn't care what you name your functions. You could name it a bunch of random characters. R is going to say, okay, I'm a computer. I don't care what you name it. I'll find it. But again, for the people who will read your code later, you should absolutely name your functions after the action that they are doing in a descriptive type way. But okay, let's say I want to, again, create a function, my function. Well, that's my identifier. That's where it's going to be stored. And again, anytime I type my function, R is going to say, oh, here's my identifier, run through the identifier. Here's this object. I'm going to pull this object out to use. And, oh, okay, now the object is a function. And then, okay, we'll perform whatever operations. But okay, so we need our identifier. Then to create a function, we use, well, the function. So function means we're going to create a function. And the format is very similar to our other control flow ideas, where it's function and then we have in parentheses x. So when we create our function, x is telling R what our inputs or what our arguments are going to be. So in this case, if I write my code like this and I just say function x, it means there's only going to be one input. There's only one input or one argument that goes into this function. There's only one argument that we need to supply to be able to run the code. If I need more arguments, well, I need to specify that in the beginning. So if I needed, say, 3 arguments, I would say, okay, well, we need x, y, z. And these are the variables that are going to be used in my code. Now, the x, the y, and the z, again, they're going to be used in my code, but remember, whatever happens in my function stays in my function. So I can use the x, y, and z in my function, and it's not going to affect whatever values x, y, and z might be outside of that function. So again, that's the really nice part. So you can store whatever you want outside your function. You can create your own functions using any variables you want, because you know that they're never going to get crossed up or mixed together. Now, once you have your function defined, you have your code body. And again, like I said, kind of like the other control flow problems, we surround our instructions, or what we want to be done, in braces. And again, typically we want to set it up so that the open brace is the last symbol on a line of code, then your code body, so whatever the instructions are, start on its own line, and then you finish up with the closing of the code body. The end of the instructions is your ending brace or your ending squiggly bracket. And again, that would typically be the first symbol on the next line of code. That's the format we use for writing code. All right, so let's do an example. Let's build our own function. So I found this data set called Seattle Pet Licenses, which has 66,000 entries for the pet licenses issued in the city of Seattle. I have kind of cleaned this up a little bit so that we only have 4 variables: pet name and license number, breed, species. But again, we have all 66,000. Now, again, let's say I just want to kind of play around with this a little bit, and I want to see how many times specific names show up. Like, how are how many times do people name their pets specific things? Well, we know how to write that code. So let's say I want to check one specific name. I want to see how many people named their pet Barkley. Well, we start with my data frame, Seattle pet names. I want to pipe that into, and again, I only want the observations where the pet name is Barkley. So that's my filter function. So I'm going to filter the pet name equals Barkley. And again, I need to use the double equals because, again, we're checking a condition. I need to use quotes because it is a character string. And so, again, that's going to take my data frame and filter it to just the entries where the pet name is Barkley. And if I want to know how many times it shows up, then the easiest code to use then would be n row, how many observations there are. So if I run that code, I'm going to get the result 29. So it ran through, so 29 people named their pet Barkley who ended up getting pet licenses in Seattle. Now, let's say I'm doing this and I want to check a different name later on. So again, I'm playing around, I'm doing a bunch of exploratory data analysis, and I know that I'm going to check a bunch of different names at a bunch of different times. And again, I'm just kind of working with the data. Well, I don't want to necessarily have to write those 3 lines of code every time I want to check a pet name. So what I can do is write a function so that I can now basically count how many times a certain pet name shows up with 1 line of code instead of having to rewrite all 3 lines of code. And here's how I'm going to do that. So writing my own function, and first of all, I need my name, and so count names. And again, I tried to make that a verb, right? What is my function doing? It's counting. What is it counting? The number of names. So again, my function name is fairly descriptive. I'm making a function, so function count name. My argument, my only input is going to be the name. So I only need 1 input or 1 argument for this particular code. So just X, that's it. Then my open brace, and then my code is, well, basically what I just had before. The pet names, so I'm going to take that data frame pet names, I'm going to filter it by the pet name being equal to X. All right, and then I'm going to pipe that into n row to count the number of rows, and then my ending brace on its own line to specify that I'm done. So again, that variable X, again, I could have defined X to be 2.17 like I did before, and that value will still be in X. But again, when I create my function, I'm going to create a new input, and I can, again, like I said, use X again. It's not going to affect anything outside of my code. And so the only argument I need to supply now is going to be what that pet name is. And see how I use that in my code. So my input, my argument, is going to be the name of the pet. And then I'm using that variable inside of my function as, in this case, I'm checking it against the other pet names. So again, that's how I would write my code. And again, that's why I only need the 1 input. If you wanted to do count names for different data frames, like let's say you had a bunch of different data frames, you might need 2 arguments, 1 to supply the data frame to use, 1 to supply the name to use. But in this case, again, I'm just working with Seattle pet name, so I only need the 1 argument for my new function. Now, that last line, n row, that is what's going to be returned. Now, that's what happens by default. The last line is what is going to be returned. That means that's what the output is going to be at the end, is going to be, well, however many rows there are. And again, it's going to output it as just, in this case, the number. It's going to count the number of rows and output just the number. If I want to do anything differently, again, I'd have to specify that specifically or put like a break function in my function. But again, I just want to return the number of pets that have that particular name. So here's my function. I've defined my function. It now exists as an object inside of the R environment. So I can call it, and now I write, okay, count name, call my function, and my only argument is that name. Now again, it is a character string, so make sure to put it in quotes. So I want to count how many times does Barkley show up, and boom, the output is 29. And again, it gave me the correct answer because I know my code was, well, correct. And again, it's always a good idea to double check to make sure you're getting the right result when you create your function. Make sure it works, right? Do a little bit of testing there. But the nice part is, again, maybe I do a bunch of analysis and now I want to see, well, how many times does the name Opie show up? How many people named their pets Opie? Instead of writing all the code again, well, I have my nice function that does the same thing over again. So count name, and this time I supply Opie. 18 people named their pet Opie, and it was much easier to do it. And I can check however many other names. Maybe I want to check Rex and Rover and Spot. I don't know. But instead of having to rewrite my code every time, I now have a nice function that works for this particular project. All right, so let's wrap it up. can you answer the following question? So first of all, if you want a function to ignore missing values, what argument can you supply? What would you supply as one of your last arguments in your particular function? Make sure you know that one. Very important. Number two, think about this one. This is more open-ended. Can you write a function that's going to find the average of all values in a given vector? So if your input or your argument is a vector, can you write a function that's going to find the average of all the values in that particular vector and then return that value? How would you write that? How would you set that up? Kind of more of a conceptual question. All right, but that wraps it up for this video. I hope you learned something, and as always, take care of yourselves.